So there's a pause and play button there, and I'm going to have to, wait a minute, maybe I don't have to do it that way. Ooh. Maybe that works. Okay. And it's going. I believe it's going. There should be a little timer somewhere, so should be going. All right.
Are you going to tell me when to pause it?
Yeah, I'll tell you when to pause it if we need to. Okay, so this, you want to have this document up, because this is what we're going to work on right now. This is just an activity where we are going to just practice using the scientific method, okay? The first one is like super easy. The next one is a little bit longer, and then we'll do Parrafin paradox. We're going to do something completely different. So here are our steps to the scientific method. We state the problem, and we always state the problem. Let's see. Oh, it will. How did that happen? Anyway, we always state the problem as a question. Okay, so make sure you remember that. You'll gather information about the problem. You're going to form a hypothesis. You're going to perform an experiment to test your hypothesis, record and analyze data, state a conclusion, and then most importantly, you have to be able to repeat your work. Okay, you have to be able, and you have to have somebody else be able to repeat your work. So you have to give it to somebody with great details of how to do it, and they need to be able to do it and get the same results. Okay? All right. So here is our first problem. So here's our first problem. Erica baked her cake for her mother's birthday. When the cake was taken from the oven, it did not rise. She thought that the oven's temperature was off and it wasn't at the correct temperature, and that's probably why the cake didn't rise. So she set up an experiment to test her hypothesis. First, she put a thermometer in the oven. She turned it on, turned the dial to 375. When the preheating was done, she looked at the thermometer and she saw that sure enough, the thermometer inside the oven said 375. So her oven is heating fine. So she concluded that her oven was heating fine. So her hypothesis was refuted. We don't use the word proven wrong or proven right because it's a hypothesis. We say it either was supported by our data or it was refuted by our data, one of those two. So scroll on down, and we're going to answer these 5 questions here. Okay? So first off, and you'll just hit your text box here. To me, that would be the easiest thing to do. Hit your text box, put your text box under there. What was Erica's problem? And remember, we need to state it as a question. What was her problem? What was wrong? Why did the cake not rise? That's the problem. Why is her cake not rising? Okay? Okay? All right? What was her hypothesis?
That her oven wasn't preheating correctly.
Okay? If the oven was at the wrong temperature, then the cake won't rise. We always write these as an if-then statement. So if the oven is at the wrong temperature, then the cake won't rise. Now, you can restate that in several different ways. So don't think because you don't have it word for word like mine that it's wrong. It's not. Okay, there's lots of different ways we can say that same thing. Okay? What was her conclusion? And then in the parentheses it says, this states whether her hypothesis was supported or refuted. So, What was it? Her hypothesis was refuted. Because the oven temperature was correct. Okay? Which step in the scientific method do you think she needs to do next? So we still have the problem of her cake didn't rise. We still need to solve that problem. So what does she need to do now? She needs to go back up there and form another hypothesis. Right. So we need to form another hypothesis and go from there. With that in mind, that we have to form another hypothesis, I want y'all to take a minute or two, and you can talk amongst yourselves, take a minute or two, and give me 2 other hypotheses for why the cake didn't rise. Write in 2 other hypotheses for why the cake did not rise. So anybody got 2 other hypotheses they want to share? Yes.
I said it's used for correct ingredients.
That maybe her ingredients were incorrect. She didn't use the right ingredients. Okay. She put the wrong one. She forgot to add something. So maybe she put in the wrong ingredients, or maybe she left out an ingredient. Okay?
Could put the wrong amounts in.
Put the wrong amounts in. Yeah. Mayo? Didn't mix it right. Okay.
Did you bake it long enough?
Did she bake it long enough? Okay. All very good hypotheses. All right. So now let's go down to page 26 in this document. This is going to take us a little bit longer. Okay, so you can see with this one, it's a little bit more complicated, but we're going to follow the same basic steps. We have a problem, we gather information about that problem, we come up with a hypothesis, we test that hypothesis, and then we repeat our test. We draw a conclusion and we repeat our test. All right, so this time, the problem is that Amy and Stephanie are on vacation in Canada, and they noticed, and it's in the wintertime, so they noticed that when they're walking along, they could see icicles hanging down from the beach houses, but they were on the beach and they saw a puddle of ocean water, salt water, that was not frozen at all. Okay, so they were wondering, why did that happen? Why is it that the puddle of ocean water, salt water, wasn't frozen, but the icicles hanging from the roof, the water coming off the roof, was frozen? So that was their problem. Why? Why was one form of water frozen and the other was not? So they gathered some information. That's the first thing they're going to do. So they looked at the pool of seawater was on the sand. Maybe the temperature was different on the sand than on the rooftop. They also observed that the seawater is exposed to cold air for less time than the fresh water was. The seawater is saltier than fresh water, obviously. Using all the information that has been gathered, scientists might be prepared to suggest a hypothesis or a solution to the problem. That's the next step. Once they gather that, they're going to do an experiment. Now, let's get and talk to the experiment part for a minute. The experiments have to be done very specifically. Okay, you have to follow certain rules for an experiment. Okay? In order to be able to positively say whether your hypothesis is refuted or supported. So, we have to come up with an experiment that only changes one thing at a time. That's it. Okay? So, that is our independent variable. The independent variable is the thing that we change. So in their experiment, they came up with two identical sized buckets. They put the same amount of water in both buckets, and they're going to put both buckets in the freezer for the same amount of time. Everything is going to be the same except for one thing. To one bucket, they are going to add salt. So the salt will be their independent variable. It's the one thing they're going to change. Okay, and then based on that change, we'll see what happens to the freezing of that water. Okay, so any experiment should only have one independent variable at a time. We should keep everything else the same. We don't need to have any variables that are changing, so we call that a controlled experiment, where we are not changing anything else. And we have a control group that is just like the experimental group, but does not contain the independent variable. So that's why she set up two buckets, not just one. We got a bucket of plain water that's going to be our control. Then we have a bucket of salt water. That's our actual experiment. And we're going to compare those two, okay? So let's move down to the data table. All right, so this is the data that they collected. So once we get our data, we have to analyze our data. We have to look at it and say, what does that mean? So looking at that data in that table, what can you conclude from that? What do you notice?
The time and the temperature. Like the temperature gets colder, the time gets higher.
Okay, that is true. So the longer they have the two buckets in the refrigerator, the colder the water gets. Yes. Is there something that you notice between these two tables? This is the table for water. This is the table for salt water. Yeah.
The water with salt took longer to freeze.
Okay, so yeah, you want to look at that little asterisk right there? That asterisk means that it has frozen. It has become solid. It has gone from a liquid to a solid. So the one with salt took longer to do that. Is that the right way to say that? No, because they were both in there for the same amount of time, right? And when they measured at the same intervals. So that's not what happened. What happened? What was our conclusion? Yes, ma'am. That the salt water freezes at a lower temperature than regular water. Okay? So you can see regular water without the salt freezes at 0, which y'all all knew that already. But water with salt freezes at -10. Okay? So that's what our conclusion is, that the salt caused the freezing point of the water to be lower. Okay? right, so let's move on down then. Okay, ignore my little drawing. So move on down to the conclusion questions. We're going to answer those conclusion questions then, and then go over them. What I'm going to do is give y'all about 10 minutes or so to answer them on your own. Maybe 5 minutes to answer them, not on your own, but like y'all can work in a group at your table there and answer them on your computer. And then we'll go over the correct answers in just a minute. So if you want to hit pause for me. All right, so here are your correct answers for this activity. State Stephanie and Amy's problem in the form of a question. So here is the question. What causes the fresh water to freeze at a higher temperature than seawater? That's our question. That's our problem. Form a hypothesis. So you can state the hypothesis in either of these two ways, but you need to say something about salt being present and that causing a lower freezing point. Okay, so if salt is present, then the freezing point will be lower. According to the data above, at what temperature did each experiment begin? They started at 25 degrees Celsius and then they went down from there. What time intervals? Temperatures were all checked at 5-minute time intervals. And what conclusions can you draw from this? That the salt lowers the freezing point, which is what we were thinking in the first place. At what rate? What can you say about the rate at which the temperature in the freshwater container dropped compared to the rate at which the temperature in the salt water dropped? You really can't say anything about the rate, okay? Because that was not, it wasn't that, it was that it froze at a lower freezing point, okay? So the rate at which the temperature in the freshwater contained was the same as the rate at which the salt water contained. The rate of temperature change was the same for both. It's just that when you got to -10 for salt water, that's when it froze instead of at 0. Okay. Independent variable. We already talked about that earlier. Our independent variable is going to be the addition of salt, which means the dependent variable is what? What changed as a rate, as a result, not a rate. What changed as a result of adding salt? Can't just say temperature.
The temperature of the salt froze.
There we go. We can say the freezing point changed or the temperature at which the water froze changed. We can't just say temperature. Why can't we just say temperature?
Temperature of what?
Yeah. Both temperatures were the same in both containers. So that wasn't a thing that changed because we added salt. The freezing point changed because we added salt. So the dependent variable is the temperature at which the water froze. Or we could say freezing point. Okay. Explain why detailed step-by-step instructions are necessary for part of a scientific experiment. Why do we need to have it detailed? Why was it you had to have 2 buckets? Then you had to have the same time intervals and the same temperatures and the same. Why is that important?
So it can be repeated.
So it can be repeated, yes. Because that's the last step of the scientific method is it has to be repeatable by somebody else, okay? Number 10, there is not a right or wrong answer for that. You're just going to come up with your own experiment and your own procedures to test whether water heats up faster with direct sunlight or sunlight coming in at an angle, okay? So everybody's maybe a little bit different, and that's fine. So please don't write down for your answer. Answers will vary because that's not the answer. I've actually had people do that before. I need to know what you think as far as setting up an experiment to test whether water is going to heat faster with direct sunlight or indirect sunlight. Whatever you write down will be fine. Okay? All right. Questions on that? Okay. Then, if you're done, go ahead and click turn in, and we'll get that out of the way. If you're not done, if you're still working on number 10, that's fine. You can turn it in up until 11:59 tonight, I think. All right. Okay, so let's go back to day 1. Go back to our day 1 folder and scroll down in our day 1 folder and click on Parrafin Paradox Scientific Method. All right, so this is another little activity we're going to do. Hang on before you click on anything. Don't click on anything just yet. Hang on. You already saw this now. Okay, so with this activity, it's what we call claims evidence reasoning. That means you're going to have to identify a problem. You're going to make a claim about the solution to that problem. You're going to provide me some evidence for your solution and the reason why you think that is correct. So to start off with, rather than put all your stuff in this document right now, I want us to do this Jamboard. So go ahead and click on that, open it up. And hopefully, because we did it last period, hopefully it's right. And yes, it should have like 4 pages. Okay. So what Jamboard does, have you ever used Jamboard before? Okay. So what Jamboard does is it lets everybody, so you can see y'all are all up here, it lets everybody work on the same document or add to it. Now, to keep things from getting like super terrible confusing, what we're going to use is this little thing over here, that one right there, is a sticky note. So if you click on that, it should bring up a little colored square, and you will put all your answers in that colored square, and then it will go up here on this board. Okay? And so we'll be able to see everybody's ideas at one time, or over time. And we're going to use that for our claims evidence reasoning. Okay? So, before we get to that, though, we have a paradox to look at. I know what a paradox is. Okay. All right, so we have this block of paraffin. Can you see that in the screen there? Just tell me to hold it up.
There we go.
Okay. So we have this block of paraffin. So I want y'all to just tell me some things that you notice about this block of paraffin.
Rectangle.
Okay, rectangular. It's not squishy.
It looks like that.
Looks like paper. Not paper I've ever seen, but anyway. What else do we know about it? Looks like soap.
Looks brittle.
Looks brittle.
It's a solid.
It's a solid. Do we notice anything about its coloring?
Not completely see-through.
It's not see-through. Is the whole thing white? Is the whole thing looks like what? Looks like the bottom part is gray, and the top part is what? More white. Okay. All right, hang on. So we've established that it looks like the bottom part is gray, and the top part is white. Correct? Everybody watching? I turned it upside down, and what does it look like now? The top one is still white. The bottom one is still gray.
Whoa. They're the same color. They're actually the same color.
So the top one is kind of white. The bottom one is kind of gray, and I know we may not be able to see that in the camera very well, but that is. No matter which way I flip it, that seems to always be the way of it. So What could be some possible explanations for why does one look different than the other? Light. Okay. So let me take out my flashlight. Let's see if we. Okay. So I'm holding it like this. White's on top, gray's on bottom, right? Okay. Now my light is at the top. What do we notice?
Gray's on bottom.
Gray's on bottom, white's on top. Same thing. Okay? All right, so let me turn it back where it was. Now, let's put the light on the bottom.
Oh, the gray's on top, white's on
Ooh.
same thing.
Okay? So let's try the side. Okay? Turn it over. Okay, let's try switching hands. Now switch this way. Okay. Everybody's seen enough? All right, so now what I want you to do is I want you to come up with, and y'all can work as groups. So if you want to split 3s and 3s, 2s and 2s, group of 4, however you want to do it, you can work in groups. But in your group, I want you to come up with 4 sticky notes. 4 sticky notes. So every group is going to have 4 of these. Not every person, every group. Okay? I need a sticky note stating our problem. What would our problem be? Referring to this.
It's weird.
It's weird, it's not a problem. What is our problem? Why is the top one look different than the bottom? Why does the top look different than the bottom? So there's our problem. I want you to come up with a claim. So have a sticky note for a claim. Your claim, you're going to kind of follow this handout that you have here. Your claim is going to be a statement that answers your question. So your claim is going to tell me why you think one at the top is different than the bottom. That's the claim. The third sticky note is going to be evidence. And evidence is going to be stuff that supports your claim. Observations or measurements that support your claim. That is your evidence. And then number 4, your 4th sticky note will be reasoning. Reasoning. It's a justification for why your evidence supports your claim. Okay? So, split up into 4. I'm going to give you some time to work on that. I'm going to put up the 4 up here as just like general template, and then you can answer them. Okay? So, all the teams.
Who's the 4th person?
We'll have 3. Yours have 4.
Okay, you'll just take all of
Alright.
Alright, stick with that.
Miss Peter, do you want us to pause the video?
Yeah.
Yes, pause the video.
Yeah.
So we're going to look at a few of these claimed evidence reasoning. With these right now, there really isn't a right or wrong answer. You just have to make a claim that answers your question, and then your evidence has to support your claim, and your reasoning has to tell why your evidence supports your claim. So I'm not going to look at any of these and say, oh, that's wrong. That you shouldn't have wrote that. Now, I might say that's more of an observation than a claim, but that's all. Okay, so let's take, looks like these 4 pink ones right here are all right in a row. So our question is, why is the bottom gray and the top white? So that is a question. Our claim, the color difference is caused by light passing through only one side at a time, causing the others to appear different. Okay, that is a good claim. So a claim that kind of basically is based on what you observe or what you measure, and that is looking at what they observed. Okay, evidence, whichever side faces the light source is white while the opposite side is gray. So that is supporting their claim or telling why. Yeah, their evidence is what you see. Your claim is your answer to your problem. Okay, so this person is saying when they shine the light on the paraffin, the light source makes that side look white and the other side look gray. Reasoning, we experimented with the flashlight and it supported our evidence. I like this, but I need a little more detail as to when you experimented with the flashlight, what did it show? It showed that no matter which side we put the flashlight on, the side closest to the light is always white. Okay, now if you had added that little phrase in there, that would have been the perfect reasoning. Okay? All right, so that's good. All right, let's look at one more. It's like all four of these are done. So, problem, why is the top different than the bottom? This, I guess, is our claim because the light captures one side more than the other. Okay? Our evidence, when you shine a flashlight on the top part, the bottom stays gray while the top turns white. When you move the flashlight onto the bottom, okay? And then reasoning, when the light hit one side of the object, it affects how the other side looks. Okay. All right. Any others? I'm going to guess that one goes with that one goes with these. Okay. All right, so that's claims, evidence, reasoning. What I want you to do now, we're going to do another one of these. So I'm going to make another page, okay, of sticky notes. What you're going to do is you have this card, okay, this card, and it says two words on it, sulfur dioxide. And what I want you to do is I want you to take this glass rod and you're going to look through. Now, don't put the glass rod on the words. Just look through the glass rod to read the words and tell me what your observations are. And then we're going to do the same thing. I want a question, I want a claim, I want evidence, I want a reasoning. Okay? So let each person look through it. I don't have enough for everybody to get their own. Okay? So what do you see, some of you? Don't lay the glass on, don't put it on the paper, just kind of look through it. And you'll see some weird
If you get closer, it gets bigger.
Okay, but do you see something? Do you see anything weird about the words?
Yes.
It's upside down.
One word is upside down.
All the letters are upside down with the words on.
The words aren't swapped, the letters are upside down, but only one word is upside down. So, all right?
Well, that's because they're the same thing.
Closer.
You gotta see it.
Okay, so give me a claim, evidence, reasoning. State the questions, give me a claim, give me evidence, give a reasoning. Obviously, our question is what?
What does it look like?
Why is one word upside down?
That was it?
You should see that one word is upside down. Why is one word upside down? Yeah, it should be on page 4.
Wait, they do.
Yeah, put your sticky notes on page 4.
Yeah, it doesn't. That's on page 4.
It doesn't what?
Because they're the same.
Are we doing?
Okay, put it on your sticky note. Put it on your sticky note.
Same groups.
I want everybody to have a chance to think about it. So put it on page 4. If you go to page 4, there should be a clean page there. No, page 4 of the, there you go. Page 4 of the Jamboard, sorry. Page 4 of the Jamboard.
I know, but that one's not.
Page 4, give me a question, give me a claim, evidence, and a reasoning.
The letters are the same. Upside down.
Why is one word, is it the same word for everybody? Which word is upside down?
Sulfur.
Is everybody sulfur upside down?
What did it say? Look, if I flip this B around, I mean, like upside down that way, it's going to look the exact same way. But arm, I did that. Why is it getting Sorry, my eyes are watering. The game is just like going in my eyes.
It doesn't say songs. We did the site.
I got it. Oh my.
We should do green. Line is so for line is one word upside down.
No way.
Somebody can call for me. The glass turns the words upside down. Okay. Evidence. The letters dioxide look the same mirrored as they do normal. Sulfur, however, looks different. Reasoning. Dioxide upside down would still be dioxide, but sulfur would be different. Okay. All right. So, few little things we might change is when I read this claim and it says the glass turns the words upside down. Are both words turned upside down?
No.
Yes,
From
they
what
are.
from what you see, are both words turned upside down?
Yeah. But one just
Yes.
is.
There we go. Yes, but it doesn't look like that at first. Okay, so you might want to change that and make it look like the glass makes it appear that only one word is upside down. Okay, so to make that a little bit more clear. The claims, the evidence and the reasoning are good, but I might, on this evidence one, I might say something like, I might bring in that only one appears to be upside down. Okay? Because these two statements are they're going to be similar, but these are almost identical. So you might want to say something about what you're seeing, what you're observing. Okay. Let's look at this one. Why is one word upside down? Claim. Are we rolling?
Yes.
Okay. Dioxide upside down still spells dioxide and looks like it. So both words are upside down, but it appears to say, okay, I like this claim because it's detailed. It's detailed and brings in what we see. When you flip the paper upside down, the word is still dioxide. Okay, reasoning dioxide looks the same. Okay. Might want to expand this just a little bit so it's a little bit clearer with what you mean. Okay? But that's good. Only the first word is switched because the second word is the same upside down as it is, same up as it is down. Evidence, when you put the tube on the word, the farther away you go, the smaller it gets. But if you get closer, it looks a little bigger. Okay, that is an observation. But does that observation have anything to do with our claim? Not really. It's a good observation, but it doesn't answer our question. Okay, so the second part does. Dioxide is not upside down because it is like a mirror. And then you give your reasoning over here. Okay? So any questions about what claims evidence reasoning is? It's one of those things that's just going to take practice because I understand evidence and reasoning seem very, very, very similar, and it's going to be easy to get them confused. But we will be doing a lot of these throughout the year, so hopefully by the end of the year we'll have it a little more down. The other thing you have to remember is that with our census questions, our long through response questions that we have on our tests and so on, they're always going to want to know why something is the way it is. That's where doing these claims evidence reasoning is going to help us answer those questions better. Okay, because we're looking into why. Why is it that way? Don't just state what it is. Tell me why it is that way. Okay? Any questions? Okay, so what I want you to do for submitting the Parrafin paradox lab is I want you to take your claims evidence reasoning for both of these, for the paraffin block and the sulfur dioxide, and I want you to take this information and put it on the PDF that's in Schoology for this lab. Okay, so let me go back to Schoology and show you, what I'm talking about with that.
Is it open with Tammy?
Open with Tammy, yes. All right, so if we go back to Schoology, here's our Parrafin paradox lab. You're going to open with Tammy. And when you open with Tammy, okay, so when you do, this is what you're going to get. And so you are going to take the information that you wrote on your sticky notes on your Jamboard, and you're just going to put it in here. We are not doing fortune-telling fish, like I said. They didn't give me any fortune-telling fish. I wanted them because I thought, what the world is that? But they didn't send it. So we are going to do the sulfur dioxide, and we are going to do the paraffin paradox. Okay? You'll just take what you wrote on the sticky note, and you'll put it into the boxes on this handout, and then click Turn It In. Okay?
Yes.
All right, so it's possible that you could get all of that done before you leave, because we get out of here at what, 12:10?
Wait, which one?
Yeah.
Where the
So let's get this. Let's continue working on this and get it turned in before you leave out of here today. Okay?
They do have proof on it.
Thank
Yeah, no, if you do the other one, oh, sorry, I don't.
Y'all can go ahead and hit
Other ones,
stop
like,
on that recording, and we will be done.